So thank you to everyone for joining us today for this virtual LF Decentralized Trust meetup. We have a discussion today with Anisha from Bloctopus. We are going to discuss Web3 Virtual Machine for Agentic development and testing. And with that, Anisha, please take it away.
Thank you so much, David. Hi, everyone. Thank you so much for having me here as a speaker. We, as a team and even as an individual, we've been working on open source contributions for many years now. So it's a huge pleasure to talk about some of the work that we've done over the years and how it has come to sort of transform the way or play a part in transforming the way DevOps is done in decentralized systems, specifically blockchains. I'll just start with a quick introduction and then walk you guys through what I'm going to cover today. I'm the co-founder of Bloctopus, and we are basically a DevOps company that started almost 3 years ago. We originally started working with the Ethereum Foundation on a project that aimed to simulate real-world blockchain environments in the most realistic way possible. So we started with that, and as part of that effort, we leveraged an open source. So around that time, a technology called Kurtosis went open source. And we sort of leveraged it and maintained it and built on top of it, which is kind of like a fancy Docker Compose. And the result was we were able to create a system that is very, very good at simulating blockchain environments in a way that's as realistic as you need to be, but also fully parameterizable. Long story short is that that technology ended up being used a lot by definitely the Ethereum Foundation. So it was then used for a lot of the DevOps work, a lot of the network upgrades that Ethereum went through, but eventually also adopted by a lot of other blockchains like Polygon, Optimism, Thorchain, and many others. Right now, what we do is we work with different large blockchains, layer ones, layer twos, and we create kind of forking infrastructure or sandboxing infrastructure for these large companies. Which can be private, it can be public facing, it can be for developers from more of a developer relations perspective, or it can be for clients for more like building a client pipeline and providing them a realistic sandbox to go through the flows of tokenization or staking and things like that. So that's a bit about us. So today I want to cover a little bit of the open source work that we have done in the past and that we're still doing, specifically how Kurtosis has basically enabled DevOps in blockchain. And some of the major use cases, which is with the Ethereum Foundation and with other chains. And then I want to get into a virtual machine, one of the biggest use cases for this DevOps infrastructure that we find, which is basically agentic DevOps, right? And that I think is the next frontier of where blockchain development is going. And I'll get into a lot of details down the road, but this is primarily what we are going to look at over the next few minutes or many minutes. All right, so let's get started. So basically, Kurtosis is essentially an open source dev environment engine for blockchain infrastructure. You can kind of think of it as a fancy Docker Compose. It handles the complexity of spinning up these ephemeral dev environments. And it's fully open source. Linked these slides will be available after the presentation, so you can take a look. But primarily, it's made of a packaging system, which is used for distributing backend stack definitions, and which can run basically on any underlying Docker or Kubernetes cluster. A runtime with a per stack file management system for reproducibility, initializing the state of that stack, and basically a set of tools to enable devs to interact with their stacks, similar to how they would on Docker or Kubernetes. So, um, yeah, so this it's not a Web3 specific technology, but it is very good at simulating decentralized systems because it can reuse the logic in any stack definition for local development, for scheduled testing in CI, and any ad hoc large scale testing on Kubernetes clusters. And it gives other developers, and this is why it's very powerful for bootstrapping a developer ecosystem because it gives other developers a way to spin up your application, in this case, let's say the EVM or any other tech stack, and commonly used variations of it. So it's very modular with a simple one-line command through these kurtosis packages, which are kind of like Docker images and other parameterization systems. So what happens is it can handle complex setup logic in the backend stack and passes arbitrary data between services as they start up and enforces arbitrary wait conditions. So so this is just to kind of show you the main differences between Docker Compose or Helm charts. Kurtosis is kind of a layer above, an abstraction layer above Docker Compose or Helm, and that allows us to introduce some features which improve the experience of spinning up these ephemeral stacks, right? So we already mentioned the per stack file management system. There is a lots of parameterizability, especially as you'll see when I'm going through the use cases of like each node and each network parameters, which gives users a very powerful and flexible way to affect the modifications in their stacks. And there is a first class plug and play composability. So users can import stack definitions into larger stacks, and this experience is very more optimized. Um, yeah, I think we already, as I said, maybe we can get straight into a live example of how this actually looks when you're simulating live blockchain environments using a technology like this. Um, the other thing to note is that there is currently a kurtosis catalog which is live. Um, this slide doesn't have the link, but I can drop the link for it later as well. This catalog is basically all of the components that you can plug into your dev environment, essentially. So as you can see, it's much more than just a simple blockchain, right? So you have different blockchains, different consensus mechanisms, but also a lot of components that complete the dev environment. So in this case, some of the featured packages are Chainlink for oracles, Block Scout for Block Explorer, the Graph package for indexers, of course, some local frameworks like Hardhat, and many more. So this catalog is growing as we speak, and there's lots of different projects can contribute their own components to it, which can then be plugged into dev environments in a very easy way by any developer that wants to create a sandbox of sorts. Um, okay, so let's look into some of the use cases and how this really transforms blockchain DevOps. So we'll go through the EVM orchestration flow, where we essentially spin up a fully customizable tech stack, which includes the consensus layer, the execution layer, validators, and each node and network parameter is fully customizable. There is there's a lot of features like you can scale the network from running a single node to hundreds of nodes. It can be a forked network, non-forked network, and all of these parameters can be set very easily in a simple JSON file. I'll move on to another. Yeah. Okay. I hope you guys can still see my screen. Um, so this is typically how what a use case for kurtosis looks like, right? You create a network, you pick between any blockchain or any decentralized stack. These are just some of the examples that are on the UI. You'll notice that this includes EVM and non-EVM stacks, which actually makes this technology very powerful, right? Because it can really work with any kind of a decentralized system. So you choose, let's say, Ethereum, and then this is where you get to choose a lot of the node and network parameters. So there's the height at which you want to fork. And well, I've dropped the GitHub to the underlying repo that's powering all this. And there's actually lots more parameters that can be customized, but this is just a very simple UI to showcase some of the things that can be changed. So, you have everything from chain ID, block time, gas limit, etc. for the network. And then you have node level parameters. So for every node, you're basically able to choose the execution client, the consensus client, the CPU, memory, etc. And then the network that we will basically spin up can be a combination of any different number of nodes, an arbitrary number of nodes, and each node can have its own parameter based on what you define. So it's a very modular infrastructure, and once you're ready to go, you can start the network. For now, we'll take a look at a network that I already created. And so the other thing is that these networks can be deployed in the cloud or locally. It's very important to have a cloud-based deployments, because obviously at some point these are very large networks and it's not really possible to continue to work with them in your local environments. But it's configurable based on what the developer wants. So if we look at a running Ethereum network, obviously, what you get is a very quick sandbox, a block explorer. So this is where all of the catalog that I showed earlier is used. So we use, for example, the Block Scout package for running the block explorer. We use the RPC. We have an unlimited faucet, and there's lots of kind of plugins which allow you to complete the dev environment. So you can install Chainlink price feeds, data feeds, um, eventually in a private sandbox or in a white label sandbox, you can have your own infrastructure. So essentially, you can imagine for a tokenization company, there is a private devnet that's running. There are a lot of the dependencies, so MPC providers, wallet providers, oracles, etc., and then their own infrastructure that actually does the tokenization, which is one of the things that you could do with a modular infrastructure like this. There we go. Yeah. So coming back to where we were. So this is kind of how you orchestrate a fully customizable stack for EVM or for any other tech stack. There are other things that we can do specifically around cross-chain environments. So, for example, you can, because this actually spins up a realistic network from the consensus to the execution client, you can then connect it with any off-chain components. So, essentially run a full version of layer 0 or wormhole or hyperlane using these, or aglayer, in which Polygon has done using Kurtosis based infrastructure. So, so yeah, coming to the next part of this presentation is the AI side, right? So what we found at some point is that there are a lot of different ways in which this DevOps infrastructure is used. But one of the most interesting things is for agentic DevOps, which goes a bit beyond regular DevOps. And we started thinking about, actually at the very base, what's holding back, or what's the future of blockchain development, right? So we know that all code, or most code in the future, will eventually be written by AI. But right now, the critical missing piece is knowing whether that code works. So we see a lot of headlines today where big tech is saying 30 to 40% of the code is being written by AI, maybe less, maybe more. In our experience, for blockchain companies, that number is much lower. And so the core issue really is that AI lacks sometimes lacks the knowledge and context of how blockchain systems actually work, or how certain languages actually work. But more importantly, it also lacks the environment and the tools for writing code efficiently. So, because on-chain environments are fairly complex, they have different components, as we saw in that Kurtosis catalog. There's oracles, there's off-chain components, on-chain components, there's the full EVM stack, and then there's dependencies, right? Because of the composability of it, these dependencies could be multi-layered. Of course, there's wallets, oracles, lots of DeFi protocols, etc. And AI cannot safely interact with on-chain environments. There is no real way to bridge that gap between the environment that AI operates in, whereas the versus the on-chain environments. And that's the main reason that we found the main reason why a lot of the development actually cannot be done agentically. Because what ends up happening is agents often produce code that doesn't work or fails on chain. Users can't give AI models mainnet private keys, of course, for security concerns. Models work very iteratively. They can spend a lot of mainnet funds. You can allow agents to use local tools like Hardhat or Foundry, but those local environments are fairly limited in terms of not having any of the additional components or off-chain components that are fully available on mainnet, right? So if you speak with anyone that's building, let's say, a cross-chain application, most likely they're building directly on mainnet because their local tooling is not going to support a very realistic environment of it. And that's why they're not so easily able to connect their Claude code to that environment because it is the mainnet environment. So what we're building now is what we think is the ultimate use case for DevOps, or is basically a virtual machine for agentic DevOps. This is a very high level kind of architecture of how this works. But essentially, if you see, there's a coding agent and there's a testing agent that works in parallel. This testing agent has access to a lot of tools which it otherwise wouldn't have, which basically allows it to spin up very, very realistic blockchain environments, deploy the code written by the coding agent on those blockchain environments, test it, collect the feedback, and then go back and fix the code accordingly. Uh, the objective with an infrastructure like this is that, of course, you give it the knowledge and the context that it needs, but more importantly, it gets the environment and the tools that it needs to autonomously complete the testing and the building cycle, right? And so this is a very simplified version where essentially the testing agent would have access to a lot of kurtosis based or other DevOps tools. It would have the ability to spin up these networks, and it would essentially close the loop along with the coding agent and keep working until certain test cases have been satisfied and the code is running as it should. All within a single prompt or single cycle. Um, However, there are lots of complexities with a model like this, and there's a lot of research going on both in-house as well as externally on fixing these problems. So our goal here is to have a Web3 virtual machine that can build blockchain infrastructure and applications up to 1,000 times faster, more accurately, and fully autonomously. But at the same time, it also has to optimize for token and gas costs, right? So one of the challenges that we face is that giving these agents access to tens of thousands of tools is very powerful, but it obviously overwhelms the context window. Agents suffer from a lot of tool space interference. You can have a lot of drop in the accuracy, execution can be slow, there can be latency, and basically the recovery becomes a bit brittle, right? So for example, one of the research projects which is about to conclude next quarter is being led by one of the leading researchers from the University of Southampton, Dr. Leonardo Aniello, and where we're basically working on shipping a production quality general MCP aggregation layer. The idea is that it's able to integrate multiple MCP servers and tools, which can be the browser, file system, blockchains, etc. And it's able to discover and select only the relevant tools in a very dynamic way. So it only exposes a small focus set and keeps the agent context aware without overwhelming the context window, and makes sure that the tools that are available to it are less than about 10 or 20. And obviously, the idea is that as that plan evolves, it should improve the token efficiency and the Web3 gas compared to a non-aggregator system. And eventually, this would be shipped with case study, open source GitHub repo, and a lot of dev tools and a Web3 MCP in a single agentic workflow. So this is one of the researches that we're doing. The ultimate architecture of something like this would basically implement a global catalog, which integrates multiple MCPs, then a retrieval and ranking tool, which extracts the metadata and passes the documentation from each tool for comparison, and basically performs a coarse retrieval and re-ranking to score each tool. Then you would have an intermediate MCP aggregator, which mounts multiple MCPs from the global catalog and dynamically produces that focus set. And then you would have a context to tool pipeline essentially, which integrates with the MCP aggregator. So this is one of the things that we are doing now. The first iteration of this virtual machine for blockchains would be releasing in the next months by March 26th. So happy to give early access to anyone. The main objective here is empowering AI agents with an underlying DevOps infrastructure, which enables them to uh, deploy and test and then build iteratively, and essentially closes that gap between AI agents and on-chain environments, which we think would be very powerful for blockchain development and for transforming the industry from going from 10 to 20% code written by AI to much larger numbers, probably not 100%, but closer to 60, 70% in the future. Um, yeah, if there are any questions or if there's any part that you'd like me to go deeper into, happy to answer them.
I'm not seeing any questions on the YouTube stream. Anybody have questions on Zoom?
Perfect. I think, David, I'm going to share the links with you for some of the repos that I mentioned in the presentation, if any developer wants to take a look at it. And I think we're all set.
Great. Yeah. If you send me those links, I'll send the links and the recording and the slides out to everyone who signed up. Great. Well, thank you, everyone.
Brilliant. Thank you, everyone.